for some reason your parents dug a hole and put you in the bottom of it. Okay, and you're holding it, I don't know, a tennis ball. And the tennis ball is 7 feet below ground level. Okay? Yeah, the level of the ball is 7 feet below ground level. So you're going to throw the ball straight up in the air. It's going to come back down, and you're going to catch it. Okay? And the story says you know that the ball was at ground level at 2 seconds and at 4 seconds. So we know 3 points. We know where it began, and we know how long it took to go up and be at ground level. It went above ground level and came back down, and we know how long it took to get to that point. Okay? So there are 3 points we know. We just need to put them in XY form. What would the first point be? 0, and how low was it? -7. So the first point is 0, -7. Okay? What's the next point we would know? At 2 seconds, how high is the ball? 0. So 2, 0. And then what's the third point we know? 4, 0. So I'm going to graph 0, -7, 2, 0, and 4, 0. And I'm not going to draw the curve yet because I don't know how high it goes. So pull out your calculators. Let me show you again how to find the equation if you know 3 points. So everybody push stat. Okay, does anybody have an 82 or an 85 or an 86? Okay, good. So stat and then push edit. And your L1 are going to be your X values, and your L2 are going to be your Y values. So enter the points 0, -7, 2, 0, and 4, 0. You just go right here and enter 0, 2, 4, and then go over here and enter -7, 0, 0. Anybody having trouble putting those in? Go to the top, push clear, and hit enter. And then go to the top, clear, yeah, and then you don't have to delete them all. Anybody else having trouble putting those numbers in? So push stat, edit, go up to the top, push clear, and hit enter. Now put in those numbers. Anyone else having trouble? Okay. Once they're in your stat, we want to find the quadratic equation. Okay? So I'm going to push stat, and then the middle column is the calculate column. So go to the right, and we want to find the one that says quadratic regression. So that's number 5. And then look at 7. 7 says quartic regression. Don't get those confused. So push number 5. So push stat, calc, and then number 5. Did yours say X variable, Y variable? That's what mine says. Okay. So hit enter. If yours has a big list, go down to where it says calculate and hit enter. And you should get this. If you don't get that, let me know. Uh-huh. So you got to go down to calculate. Yours just looks a little different. Same thing. Okay, everybody get this? You didn't? Enter. There you go. Okay, let me interpret this for you. It says your equation is ax squared plus bx plus c. And then it tells you the values of a, b, and c. So the equation is y equals negative 0.875 x squared plus 5.25x minus 7. So that's the answer to number 2. Nice pencil. Okay, now we need to figure out the maximum, so I want to put that in my y equals. So go into y equals and type in negative 0.875 x squared plus 5.25x minus 7. And then I'm going to push graph. You should get that. If you don't get that, raise your hand and we'll come help you. You getting it? So you want to push zoom standard, and that will fix it. Uh-oh, something's wrong. This is supposed to be negative. Now try it. There you go. Once you have this graphed, we need to know the maximum point. So, everybody look up here. Push second calc. See that red button on my calculator? Okay, and we want to go to maximum. Now, the maximum looks like it's somewhere around x equals 3. We need to pick a left bound and a right bound and a guess. You can either type in numbers or you can just scroll. So my maximum is right there. It says, tell me something to the left. So I'm going to go to the left a little bit, and I'm going to hit enter. Then it asks for a right bound. So I'm going to go somewhere to the right, and I'm going to hit enter. Now, do you see those two arrows? Is my answer between those two arrows? Yes, so I did it right. Now I just go as close to the answer as I can, and I just hit enter. And it says that the maximum is 3,0.875. If you got something different, then you made a mistake. No, that's what you got. 2.9999999 is really just 3. Okay, let me look at yours. 875. Let me try it. Your equation was a little bit off. We can now graph the maximum. So the maximum is 3 and not quite 1. Okay? I can draw the quadratic. Number 4 asks, how high does the ball travel above the ground? How far is it from here to here? Not quite 1, right? If you look at the maximum point, at 3 seconds, it's 0.875 above the ground. So the max is 0.875 feet. How long is it going to take before you catch the ball again? 18? No. Why 6, Cameron? So Cameron said, well, it took 2 seconds to go from here to here, so it must take 2 seconds to go from there to there, which is right, 6 seconds. You could also say it took 3 seconds to go from hand to maximum, so it must take 3 more seconds to go from the maximum to where you can catch it. So the answer is 6 seconds. Okay? And if you know 3 points of a quadratic, you can always use your calculator to figure out what the equation is. But what if you only know 2? Look down below. Suppose a quadratic equation touches the x-axis at 3 and at 6. So we have our 2 roots, here and here. Number 6 asks, can you create a quadratic that fits the information above? Well, it's kind of tough. We don't know yet, but is there a quadratic that hits both of those? Yeah, this one does. Is that the only one? No. This one does. Or this one does. What do we need in order to create one quadratic? We need another point. So if we knew that point, then it would be the green quadratic. So the answer really is no, not yet. Number 7, what do you need? You need a third point. But having said that, we can kind of create one. We can create one of the many. We don't know exactly which one it's going to be, but we can create one of them. Number 8 asks, what are the roots of a quadratic? What does it mean to be a root? It's where the graph crosses the x-axis. So that's the answer to number 8. A root is where the graph crosses the x-axis. Number 9 asks, what are the other names for roots? What are they also called? They're also called zeros or x-intercepts. Either one. Okay. 10, I don't know why it has a question mark on it. Create a quadratic satisfying the 2 roots. So we have a little trick we can do to make a quadratic equation. So somewhere where you have room, there's not really room on number 10, write x equals 3 and x equals 6. So those are the 2 roots. If we want to create a quadratic, we have to set both of those equal to 0. So I'm going to subtract 3 and subtract 3, and I get x minus 3 equals 0. Subtract 6 and subtract 6, so x minus 6 equals 0. So that's the first step today. Take your roots, set them equal to 0, and these are roots, and down below we have what are called factors. So when you set roots equal to 0, you create something called a factor. Now, a factor is just a number that multiplies to be another number. For instance, 12 has 1 as a factor and 2 as a factor. 3 and 4 are also factors of 12. Well, if those are factors, let's multiply them together. So draw a box, 2 by 2. Put one factor on the top, x minus 6, and one factor on the side, x minus 3, and then we're just going to multiply. So in the first box, x times x is x squared. In the second box, x times negative 6 is negative 6x. X times negative 3 is negative 3x. And negative 3 times negative 6 is 18. Is everybody okay with that? Now we look at the diagonals. My equation for number 10 will be x squared. What do I get when I combine two? Good. Negative 6 and negative 3 make negative 9x plus 18. Now, is this the only quadratic that hits those two roots? No. But it is this one. This is kind of considered the most basic quadratic. Using this equation, we could create all other quadratics. For instance, if we took this equation and we times the whole thing by 2, then the quadratic would be 2 times taller and 2 times lower. If I divided the whole equation by 4, then it would be 4 times shorter and 4 times, well, shorter basically. If I multiplied it by a negative number, then it would flip upside down. So this is sort of the general quadratic. It's the easiest one to make, but you can always multiply it by something and create any other quadratic you're looking for, whether you want it to be taller, wider, or negative or positive. Okay? So number 11, is this the only quadratic? No, it's not. There are an infinite number. So for this worksheet, we're going to practice making quadratics. So for number 12, I have x equals 2 and x equals negative 7. I'm going to create a box. What are my two factors? X and not 2, negative 2. Why? If I have x equals 2, I need to move this over. How do you move a positive 2 to the other side? You subtract. So x minus 2, and the other one would be x plus 7. So now x squared, x and negative 2 make negative 2x, x and 7 make 7x, 7 and negative 2 make negative 14. So that gives me x squared. What does the middle diagonal create? 5x minus 14. So that type is really easy. The fraction type is a lot harder. So follow closely on this one. What are my factors on 13? X minus 4 over 5 and x minus 1 over 3. Okay? X times x is x squared. X times negative 4/5 is just negative 4/5 x. X times negative 1/3 is negative 1/3 x. And then negative 4/5 and negative 1/3 So if you don't know how to do that, just type it in your calculator. These calculators do not have a fraction button. You just use the divide button. So negative 4 divide 5 times negative 1 divide 3. When you push enter, it's going to give you a decimal. We don't want the decimal, we want the fraction. So push math. So this button right here. The first one says triangle fraction, which means turn your answer to a fraction. 4/15. So this is 4/15. Anybody not up to this point? All right, now we need to create the equation. X squared. What is negative 4/5 x minus 1/3 x? I don't know. Let's ask the calculator. Negative 4/5 minus 1/3. Again, it's going to give me a decimal answer. So I push math fraction. Negative 17/15 x plus 4/15. It is simple. Oh, you mean put it in mixed mixed numbers died at the junior highs. We will never ever say 1 and 2/15 because everything we do will be improper fractions. So yeah, don't worry about switching to mixed numbers. They're so hard to deal with. We're not going to do it. Okay, we're not quite done with that. Is this the only quadratic that hits those two roots? No. Did it ask for a specific quadratic, or did it just say make one? It just said make one. Well, I don't like this one because it has fractions. So we're going to change it to one that doesn't have fractions, and it's really easy to do. Because we don't care which quadratic we're dealing with, all we care about are the roots, we're going to times this by the largest denominator, which in this case is 15. So we're going to times this by 15, just to make things easier for us. So 15 times x squared is 15x squared. What is 15 times negative 17/15? Negative 17x. And what happens when we times this one by 15? We just get plus 4. If we had a different one that looked something like this, x squared minus 3/4 x plus 5/12. What would I multiply by? 12. So I times by 12. What does that give me? 12x squared. This one's a little bit tricky. What's 12 times 3? 36. And what's 36 divided by 4? 9. If you don't understand that, you can just do 12 times negative 3/4, math fraction, negative 9. I didn't need to do fraction, but. So this would be minus 9x, and what's 12 times 5/12? Just 5. Okay. So turn the paper over. The answers are there. You need to show your work to create quadratics for each of those. Good luck.